Welcome to the channel again, my friends. Today I'm focusing on functions, particularly the two functions, that is hyperbola and a straight line. I'll be discussing very important phenomena of these two functions. Please pay attention and listen carefully. We are given f of x, which is 4 divided by x minus 3 plus 2, and g of x, which is x plus 2. F of x, if you look at the equation, is the hyperbola, and g of x, if you look at that equation, it is a linear graph, which is a straight line. Now, in these two graphs, you will be expected to answer any question which is given here. Now, let me look at my questions that I formulated for you. The first one says, determine the equations of the asymptotes of f. Now, if you look at this graph, it is asymptotic because we have a fraction. There is a denominator there. Therefore, that means that you will have an asymptote. Now, when they say to you, determine the equations of the asymptotes, first of all, what are they talking about? They are talking about the horizontal and the vertical asymptote. The vertical asymptote would be the denominator there, x minus 3. Now, how does this become an asymptote? It becomes an asymptote in such a way that x is not supposed to be equals to 3. If x is equals to 3, then the equation of f would be undefined. Now, what is an asymptote? An asymptote is the line that the graph approaches, but it never touches. I repeat again, asymptotes are lines that the graph will be approaching, but it will never touch. Why is it not touching? It is because your graph is not allowed to be that particular value, or it cannot be that particular value. In this case, our graph is not allowed to be equals to 3, because if it is equals to 3, we will get an undefined situation. Number 2, your value of y can never be 2 in this case. Why? Because you are adding something to 2. It means your value of y would rather be something which is greater than 2, but it would never be 2. It would be greater than 2 or less than 2. Now, determining the equations of the asymptotes, what do we do here? Like I said to you, x is not supposed to be 3. That one is your vertical asymptote. The value of y, if you look at green there, cannot be equals to 2. This is your horizontal asymptote. The asymptotes are from here and there. Now, if they say give the equations of the asymptotes, you have to give the x value that is not supposed to be used there. You have to give the y value that we will never get in this situation. Those are the asymptotes. Now that we have answered the first question, let's move on to the next question. Determine the x-intercepts of f and g. What are the x-intercepts? The x-intercepts are the points where these two graphs would cut the x-axis. Now, what do we know from our mathematics? We know that for x-intercept right there, the value of y must be equals to 0. In other words now, I need to tell the examiner that when I'm looking for the x-intercept of this function, I would make y 0. When I'm looking for the x-intercept of that particular function, again, I would make the value of y 0. Folks, those are the marks you really need to indicate that y is 0 in both instances. Now, let's move to the solution. You see, as I have indicated, the value of y is 0 there. Now, mathematically, I must solve for x by manipulating this beautiful equation. How do we manipulate it? You take positive 2 to the other side of the equal sign, goes there, it becomes minus 2 because it was positive there. Now, I want to stress this. Because it is a fraction, you cannot just do as you wish before restricting the movement of x. Remember, we said x cannot be equals to 3 there. Therefore, it allows me to multiply by x minus 3 throughout, because I know that this is not 0 now. Let's do that. We multiply throughout by x minus 3. X minus 3 would cancel x minus 3. You multiply minus 2 by x minus 3, you get minus 2x. Positive times negative, time is a negative, is a positive. 2 times 3 is 6. Now, we have a linear equation here. We solve for x. We group like terms. I take 4 into this side. I took minus 2x into that side. It became 2x. 4, it became negative, and 6 minus 4 is 2. Beautiful. Now we have to solve for x by dividing both sides by 2, because we don't want 2 times x, but we rather want x. X would be equals to 1. The x-intercept of the hyperbola is at 1 is to 0. Now, moving on, folks. We are looking for the x-intercept of the straight line, and as we said, for x-intercept, the value of y must be equals to 0. Now, what do I do there? Let's go down. I 0 y there, then x plus 2 is equals to 0. Now I need to manipulate and make x the subject of the formula. Let's quickly do that. Take plus 2 to the other side of the equal sign. It becomes a minus 2. The x-intercept of the straight line will have the coordinates minus 2 is to 0. We have answered the question that required us to determine the x-intercept of the two functions. Now, the next question says, determine the y-intercepts of f and g. We are looking for the y-intercepts of those two functions again. But now, what do we know about y-intercepts, my friends? We know that for y-intercept, x must be equals to 0. That means that where we see x in both equations, we are going to put 0. Now, let's move on to our beautiful solution there. Now, when we do that, in the hyperbola, if you put 0 where you see x, it is gonna become 4 divided by 0 minus 3 plus 2. And 0 minus 3 is a minus 3. We would have 4 divided by minus 3, which is minus 4 divided by 3 plus 2. Now let's move to the solution. When you add those two, you get 2 divided by 3. Now the y-intercept of the hyperbola is 0 is to 2 divided by 3. Beautiful. Now we are looking for the y-intercept of the straight line there, the linear graph. We just put 0 where we see x. It becomes y is equals to 0 plus 2, which is 2. Now, moving on to my solution. There we have it. Y is equals to x plus 2. For y-intercept, x is 0. 0 plus 2 is 2. The y-intercept of the straight line is 0 is to 2. Great, folks. Very much happy with the way in which we are progressing, and I can see some of you smiling at home there. Now, next question says, because now we've got the x and the y-intercept of the two graphs, sketch f and g on the same system of axes. Now, in the exam, it will say to you, indicate all the intercepts with the axes and the asymptotes. That is very important. Never just draw a graph that does not show those. Now, let us visit our graphs. You see now, I want to discuss all the concepts that we have been having before sketching. We said the vertical asymptote of this graph is x is equals to 3, meaning that x is not supposed to be 3. Now we go there at 3, we draw a vertical dotted line, which is known as an asymptote. And if we revisit this graph, the value of y would never be equals to 2 because we are adding something to 2. It'd rather be greater than 2 or smaller than 2. Now we go to our graph and indicate that y will never be equals to 2. Let me go and do that mechanically. Mechanically, at y is 2, I draw a dotted line. Now, another thing that we should never forget, we said the x-intercept of the hyperbola is 1. The y-intercept of the hyperbola is 0 is to 2 divided by 3. Now, those two values are here and there. Now, remember, before drawing your graph, the equation is telling you a story. When that is positive, I'm talking about parameters now. When that parameter is positive, it means your graph is on the first quadrant and the third quadrant. Remember, the first quadrant is there, the third quadrant is here, because your graph has been shifted 3 units to the right and 2 units upwards. Now, when we shift these 3 units to the right, it goes there, 2 units upwards, the origin is now there. Now, meaning that our graph is going to be here and here. And remember, it is curving towards the asymptotes. It will never touch them. We have drawn the graph of the hyperbola function. Now, indicate that this is the graph of f. Please, never forget. The second function is g, and g is the straight line. The gradient is positive, meaning that the graph is expected to increase. Let's go to the graph. It is an increasing function. The x-intercept was -2, the y-intercept was 2. Then our graph is drawn beautifully there. And again, label, this is G. Now, we have answered that question, and I can promise you, we are talking 5 marks here. And the function, if I may indicate to you, functions in grade 12 carries a whole lot of 35 marks in your paper 1. Okay, let's move on to the next beautiful question. You know, mathematics is so beautiful. You do it mathematically, you do it mechanically. I remember I mentioned mechanical. Now, here, we will be hitting mathematical and mechanical now in this question and this question. It says, for which values of x is f of x equals to g of x? I repeat again, for which values of x is the graph of f exactly the same as the graph of g? Now, what do you have to do here? First of all, you need to equate those 2 equations. You equate them because we say at the point of intersection of any 2 or more graphs, those graphs will share exactly the same coordinates, exactly the same values. Now, you equate f of x and g of x. Then you solve for x and y. Now, in this case, I just wanted the values of x for which these 2 are equal. Now, when I did what I'm telling you about, my answers were x is equals to -1 and x is equals to 4. And x is -1 there. I can see that it is correct. Using mechanical inspection, and x is equals to 4. Remember, 3 is before 4. Now I can see that mechanically when I inspect, my answers are correct. Remember, folks, if we say for which values of x will the 2 functions be equal, remember to equate and solve for x. Beautiful. Next one. For which values of x is f of x less than g of x? Now, you see that mathematics there can be beautifully interpreted mechanically. To me, mechanically, it says, for which values of x will f be below g? Meaning that g must always be on top and f must be below. Now, this question, I want to close it by saying, if x is less than 3, folks, can I please repeat this question? For which values of x is f of x less than g of x if x is less than 3. Now, what am I saying? I'm saying in whatever that you are going to get there, I am considering this side of the graph, not this side of the graph. I'm considering this other side. Now, how do we answer that? I'm looking for where f is below g. Now, if you look at our graphs there, from here to just before that point, g is below f. It is mechanical now. G is below f, and I don't want that. I want g to be above or on top. If you move from that orange one up until, remember now, f is not allowed to touch this line. You should be fair now. Up until before this line, we stop. We can see that g is above f. Great. Now, that means this will happen when the value of x or the values of x are between this point and this line. I repeat again, that will happen when the values of x are between this point and that line, the vertical asymptote. Now let's go and answer it. I said between. Now, I put -1, I put 3 first. I put x between them. Then, using inequality signs, when I'm moving this side of a -1, the values of x are increasing, meaning that x must be greater than -1. When I move this side of x is equals to 3, the values of x are decreasing. That means x must be less than 3. Beautiful, folks. Now, if you look at what I did here, I have even drawn an arrow to there to say, yeah, I'm looking for that part, not any other part. Let's move to the last question. The last question says, what is the domain and the range of f? You must know what the domain is. The domain are all the x values of a function. The range are all the y values of that particular function. Now, they say, what are all values of x in this particular one? Never forget what you said there. You said x must not be equals to 3, and that was the only thing that you said. Now, meaning that x can be any number which is real, but it should not be equals to 3, according to you there. Now, let's give the domain of that. The domain is right there. The domain of f. X is an element of real numbers, except or excluding 3. Now, this has perfectly answered this part of the question. Now, let's go to this part of the question. What are the y values of this function? The y values of this function, according to us there, we said would be anything which is greater than 2 or less than 2. It would never be equals to 2. You see, folks, if you pay attention into your work, you would be very much proficient. And I'm telling you now, if you are efficient in your work, that will make everything very easy. Procedural fluency. Look at what we have there. I said the horizontal asymptote is saying to us the value of y will never be equals to 2. It would either be less than 2 or it would be greater than 2. We have answered all those questions. Folks, I want to say this. If you pay attention and practice your work, proficiency and procedural fluence will come automatically. Thank you very much for watching. Please subscribe. Tell your friends to subscribe. Like our work. And leave a comment if it is necessary to do so. But please, a very positive comment, as I am also as positive as possible in as far as your mathematical achievement is concerned. Thank you very much.